Alright, this is a question 3B from the CSEC Mathematics January 2024 paper. The Jamaican patois. Alright, so here now. What I do? The diagram below shows an equilateral triangle FGH whose base is 13 centimeter. Height H. Calculate the value of H. Now what you going to do this thing? Remember, say you must just sit down and watch the whole video. You must try the questions before you watch the videos, right? So we see how this thing go. It's a 13. So from here, so all the way to here, so 13. That means, say, we see something. If you should have drawn back the triangle, like so, and this, so this is 13. Half a 13, how much? 6.5. 6.5. So this is 6.5, you know. And this would have been 90 degrees. Now they say an equilateral triangle. Now you see the line here, so you know it's an equilateral triangle, right? This angle hour. You must remember the angles in an equilateral triangle are 60 degrees. And since you cut this in a half, this is 30. But then they want again H. Right? So you can say this is a H. Right? You have this 60. You have this 60 right here, so. This is what? Opposite or adjacent this? Don't tell me no adjacent, you know, opposite. This angle upon the right hand side of the triangle. This side upon the left and right are opposite, so these are the opposite. And this 6.5 are the adjacent, it run alongside the angle. You notice? The opposite. Now come nowhere near the angle, you know. We have this adjacent brush against the side of the angle. These are the hypotenuse, but the hypotenuse adjacent to the angle too, you know, because it brush right alongside the angle. Alright, you see that? So you're going to say tan of 60 equal opposite, that's H, over adjacent 6.5. Alright? So, my gosh, where this come from? So, when you transpose H equal 6.5 times tan 60 equal what? We reach for a calculator. Alright, so what we have now? These are from some work made earlier. Make sure you calculate in a degree mode, right? Degrees, a degree mode. So 6.5 multiplied by the tangent of 60 equal 11. Roll it off to 26. Alright, call it 11.258. So 11.258 degrees. Or then not say if you write it in any 20 particular significant figure or decimal place. Right? They don't say how accurate you must round it off, but here angle, the height, I mean. No, not degree. This is where we get degree from. Centimeter. Right. 11.258 centimeter. You can write it as 11.3 if you want. They never say to how many significant figure or to how many decimal places. Right? It's a little over 11 centimeters. Question 3C now. From the CSEC Maths, January 2024 24. January 2024 paper. Alright. The diagram below shows three triangles P, Q, and R. P, Q, and R. Triangles Q and R are images of triangle P after it undergoes a double transformation. Alright. So you go from P to Q to R. Alright. Describe fully the single transformation that mapped triangle P onto R. Let me just copy this and put it over here. So we want what happened to P. Make it turn in a R. P to R. Now, suppose you imagine, say, you have this triangle here, right? Let me take this out of the way for now, and you have this. This is the triangle. You take the triangle. Notice the triangle are same orientation, flip, turn around, spin or nothing. If you go 1, 2, 3, 4 up, then 1, 2 to the right, you have R. You see it? 1, 2, 3, 4 up, 1, 2 to the right. You match with R. So you go 4 up and 2 right. What kind of transformation that? Is a slide, or what they call translation, in the form X, Y. So you'd right say is a translation, translation, that takes the form. Now remember, X move left and right. X move left is negative, X move right is positive. It move right, so a positive. How much you move? 2. Y move up and down. If you go up a positive, you go down a negative. But P would have to go up. Right? If we move to R. So Y a 4, positive 4. So it's a translation of the form 2, 4. Right? 2 in the X direction, 4 in the Y direction. You can write all of that if you want to fill out all of the space. But it's a translation of the form 2, 4. That means P go to R. You see that? After that, them say R to Q. How R go to Q now? Interesting. I want to see how R go to Q. Let me make a copy of it and put it over here so. So the question is how R end up on Q? Alright. You have R. If you translate it, you see that the orientation change, it spin round. Right? What you have to do now? You can say the distance between R and Q to the left. 1, 2, 3, 4, 5, 6, 6. So if you go 1, 2, 3, and you come right here, so. My, all this here, so. If you end up with this line right here, so. You can see that if you make one flip, 3 to the left, and with this one flip, 3 to the right, it's like a mirror. It's a mirror. It's a reflection. Right? If you go 1, 2, 1, 2, 1, 2, 1, 2, it's really a mirror. If you take the line, which line is x equal 1, this line is the line x equal 1. If you take that and reflect R over it, you get Q. Right? Once you use your imagination and see, this is how you get Q. So it is a reflection of R in the line x equal 1. Give you Q. Right? Reflection in the line x equal 1 give you Q. So that is really what happened. So you get Q. Total 9 marks. So question 3 done. Next time we move to question 4. I want you work out question 4 from now. Right? It's function. Question 4 deal with functions.